get an idea of what the sine graph looks like, we can also use the unit circle. So if we draw our unit circle, so unit circle is nothing more than a circle with radius of 1. And if theta is an angle there and P is the point XY, we know that the sine of theta is the y coordinate over 1, unit circle, so that'll be equal to 1y, or just y. So sine of theta is nothing more than the y coordinate. So if I was to have a look at what the sine graph looks like, and I'll draw some axes here. And we'll go out so when theta is equal to 0 degrees, point P is there, and the sine of 0 is 0, so it is there. So basically what's going to happen here, to get an idea of the sine graph, is that as theta gets larger, the graph will trace out what's happening to y. Now y is down here at 0, at 90 degrees y is up there, at 180 y is 0, so it's gone back to there. Where is my y at 270? It'll be down at -1. So if you like, the graph will chase the y coordinate. So 0, the y coordinate is 0, so it'll go up like this, down, back down, and then back up again. And everything in between. So at theta here, if I wanted to know where it was, that would be my theta in this instance. So it would be just the y, the length of the y ordinate would be, so that would be y units up there. All right, and you can also see that we know that sine is positive here, and sine is also positive there, and it is negative there, and it is negative there. Well, between 0 and, this is 90, 180, 270, 360. So you know that between 0 and 180 sine is positive, and between 180 and 360 sine is negative. If that is going theta increasing in that direction, if you went in this direction for theta, so here's 0 and this would be like -30, -60, -90, etc. You know that sine is negative in that quadrant, so this will continue down like this. And after you get to 360, you don't stop, you keep going, and it would continue on up as well. Okay, now first things to notice is that it repeats itself. So here, if you have one, what we call one period, between there and there, because if I pick that part of the graph up and moved it across, so this point here goes to there, the graph would repeat itself again, and if I pick this up and moved it across to the left, it would also look exactly the same. You also know that it goes between -1, a y point of -1, and +1, because the greatest y value in the unit circle can be +1 and the greatest y value can be -1. You can also see why that's a sine of 180 minus theta. Now 180 minus theta would be out here, if that was theta. This is 180 minus theta. It's going to have the same y value as sine of theta. So there is theta. This would be 180 minus theta. Would be exactly the same point there. So this is 180 minus theta. So we go, say theta is 40 degrees. This would be 140 degrees. So we got 0, 90, 180. This would be 40, and this would be 140. And you know here that sine is negative in those two quadrants. So this would be 180 plus theta. It's because you'd go around 180 plus theta. That would be 180 plus theta, etc. We could keep on going around like that. So that gives you an idea of what the sine graph looks like. It starts at the origin, goes up to 1 when we're at 90, 180, one complete cycle between 0 and 360. And that's called a period. That can be picked up and placed, and you get multiple repetitions of that. Also, you should be very aware of the fact that we could be working in radians. So if we're in radians, this is still 0. This is pi on 2. This will be pi, 3 pi on 2, 2 pi. So this would be negative pi on 2. And this would be negative pi, etc. So if we're working in radians.